Hi all. Today let us understand what is Thevenin's theorems and how to reduce a circuit using Thevenin's theorem. So, what does a Thevenin's theorem say? Thevenin's theorem states that any linear bilateral network containing several voltage sources, current sources, and resistances can be replaced by an equivalent circuit consisting of a single voltage source in series with a resistance, where the voltage sources is the open circuit voltage across the load terminals and the resistance is the equivalent resistance of the network as seen from the load terminals, with all independent voltage sources replaced by their internal resistance and all independent current sources are considered as open circuit. So it's a quite long statement, and let me reduce and simplify it. Let's take an example of a circuit. So let's say, oh, sorry, let's say we have a circuit like this, and we have a resistance like this, and this is a simple circuit, and we want to find out Thevenin's equivalent from this point A and B, right? So let's say this voltage is E with an internal resistance of small r, and this is the resistance R1, this is the resistance R2. Now we need to find out the equivalent circuit of it. So first of all, it talks about a linear circuit. Linear circuit means the component of the circuit should be linear. Linear means, for example, this is a resistance, and if I apply voltage here, if I apply voltage V1 here, so if it is R, we'll get something called I1 here, right? And if we apply V2 here, then I will get I2. If I apply V2, then I will get I2. If I plot it, V versus I, let's say V and I here, so it will be linear curve. So for V1 we'll get I1, for V2 we'll get something here, this I2, let's say. So this curve will be linear. So that is a linear circuit component, uh, where a circuit consists of linear component called linear circuit. So that the term came from linear. Now again, bilateral means what? Bilateral means, let's say this circuit is consist of two or three component like this: one resistance here, one resistance here, then one resistance here, and one resistance here, like this. And I'm putting an ammeter here, and I'm giving a voltage source here, voltage. So we'll get some current here, right? Let's say 10 ampere. Now if I change it, if I make this a voltage source, if the voltage is applied here, if the voltage is applied here, and if I connect the ammeter here, I'm supposed to get an ampere, 10 ampere here. If this is happening, then it is a bilateral circuit. So Thevenin's theorem is applicable for linear and bilateral circuit. Now this is a linear and bilateral circuit where we are going to apply Thevenin's theorem. So what it says that we need to find out the open source voltage. So if I open it, what would be the voltage between A and B? Now voltage between A and B would be something. What is the current flowing through this into multiplied by R2? This is R2. Okay. So what is the current in this circuit? It's very simple. E by small r plus R1 plus R2. No, so if this is the current, then I into R2 is what? This into R2. So that is the this is equal to VTH, right? VTH. Now what is the equivalent circuit? Equivalent circuit, we need to find out equivalent circuit while looking from this side only. This is your big eye with whatever eyelash. This is your eye, you are looking it from this side only, and from then we have to create equivalent resistance. Now remember what it says, that all voltage sources will replaced by their internal resistance while calculating the RTH, or internal resistance or equivalent resistance. So if we want to redraw this circuit, it will look like this is your R1, bigger one, and this is the small, this R, and again here is the R. So that is the equivalent resistance. So how much would be the equivalent resistance? This is the R1, this is R2, and this is small r. So it will be R plus R1, which is in parallel to R2, which means R2 into R plus R1 by R plus R1 plus R2, that is R equivalent. So with this we have got VTH and R equivalent, or it is also called RTH. So the Thevenin's equivalent circuit will look like this. So it will have an resistance, it will have this VTH, and this is the circuit. Now what is the advantage of this circuit? So this is RTH, this is VTH, and this is the A and B point. So let's say RL is the resistance connected in this point. Now we can find out the current through this part, RL, right? Very easily. What would be the current in this path? It will be like VTH by RTH plus RL. It's simple. So that is Thevenin's theorem. I hope that you guys have understood it. Thank you.